Hello, this is an ad hoc screencast. Just going to look at the use of scaling on the FFT spectrogram, selection of units. If we go back to the trends display here, this is a ESUS patient, and we're going to look at calculating spike wave index over periods of continuous spike wave, and also looking at scaling of spectrograms to help see where those state changes land. So the default values for these, actually I'll just click them back to the default values because I was clicking around in here moments ago. These are the default values, and the reason that we would change these is if we go back to that split screen, you can see here the amplitude's high enough, and these are all very, very dark. For the rhythmicity spectrogram, they're very definitely blooming for the FFT spectrogram. So if we click this, the idea is that we can click the scale and change this so that we can see changes in the delta, alpha, beta ranges simultaneously. So delta to theta tends to be higher in amplitude than the higher frequency. So by taking the square root of each value and then plotting it, you get more dynamic range, the ability to visualize that more easily. Now these values can be changed. So if we double click on this, granted these axes, this is set to master control, which means when I move the gain slider, it's going to move in tandem. And so we change this for both of these. So if we want to use microvolts or microvolts squared, this is where we could change that, and we would do it for the other trend panel as well, because we want to use the same units for each trend that are sitting there together and that are under a master control. So the master control is under the axes, spectrogram. Here's where you can change those units. So you can multiple select as well. Go to trend properties, and here I could also change the units used for them together, and you see here it went to microvolts per hertz instead of the square root value, and you can see how these bloomed quite a bit. And I could just change the gain here. There's a little bit less dynamic range. You can see that that it doesn't represent it quite as well, but given that the amplitudes are fairly consistent throughout, there's a when you have a spike wave, continuous spike wave, there's a significant amplitude in the higher frequencies. So this is a record where you're not going to see that quite as pronounced. But again, you can change the units, and that's the idea of that. So let's go back to trend properties here. We'll go to spectrum, and we'll set it back to the square root values. And again, it's just taking the square root of each value. If you're exporting these, that tells you what values they're going to be. Now, the other thing to keep in mind is this is running the research package, so we have access to the calculation engine parameters. And when I click the FFT engine to view that, we're only viewing it rather than editing it because these have already been calculated. If I want to modify these values, I'd have to clear the trends because I'd have to recalculate them. It's downsampling from whatever native sampling rate there is. That value can be changed. Right now it's going to calculate up to 32 hertz of FFT. The reason it stops there is because if you're only displaying up to 20 hertz, why calculate up to half the sampling range, which could be up to 256 hertz of values you're not going to show. Just overhead. Points per window, windows per epoch, all that's adjustable before you do the processing. When you have a research license, you can change these parameters. But the main thing to look at is that the frequency resolution by default is a half a hertz. So if I were to export these values to a trend or to a CSV, let me go ahead and select trends and show how to do that real quick. I would just put in the range of interest, and if I don't put it in a range, it's going to do the whole thing. So I'm going to put insert range. Let's just do this. Then I select the trends I want to export. So I'm going to hold down the shift key or the control key. I'm going to select these two. I'm going to tools, and I'm going to export channel trend values. And I can put this into a CSV file. Now the CSV file will have 40 columns for left hemisphere, 40 columns for right hemisphere. Each column will be 1/2 hertz, the amplitude in half hertz increments for each column. Each row will be the epoch length, in this case is 8 seconds. And those are adjustable in the FFT parameters. But to understand what it's exporting, it's going to do the microvolts, the square root value of each microvolt value, and put it into the spreadsheet. And that's why if I go and I change the units that are used to microvolts, then that spreadsheet will have microvolt values. But again, it'll still be in half hertz per column. And each row will be the FFT epoch length, and so you get 40 columns for each trend. Okay. Enough of that. So let's go and look at how to calculate spike wave index, because we have continuous spike wave during this. In fact, if we just click at this point here, we can go ahead and go back to the EEG. And as we scroll through this, we can see these spikes are marked. You can change spike detection sensitivity. Now, the papers that looked at how well humans agreed with the spike wave index calculated and persist, they use the high sensitivity. And in some recordings where that sensitivity is going to change the marking, then going to higher sensitivity will tend to have more human comparable rates, not detections necessarily, but those rates will be, and it just has to do with how people tend to mark whether an epoch is true for continuous spike wave or not. They tend to focus less on variability from one to the next, and the algorithm is a little more consistent about, well, I'm going to call this a spike and that not, because of slight differences in perception value. So by going to high, it pretty much smooths that out. These are so clear cut that going to higher medium is not going to make much of a difference. But for this, we're going to set it to high for doing those spike wave index counts. Now, let's go back to the trends. I'm not going to use this this particular range setting anymore, so I should be able to just get rid of that. No, it's not going to let me. That's okay. In Insight 2, you can go ahead and change the cursors. In fact, oh, good. Right-click. We can go to cursor control. We're going to erase all. There we go. Nice. We got rid of those. Guys, I'm going to put in a new one to mark a range of what we're going to do this calculation. So I'm going to use the trends to help me out with finding that. Now, if I page forward in these trends, I'm at an hour. We can go even higher here so we can see some of these state changes. Now, granted, as we do this, we don't have enough pixels to display all the epochs, especially if we're doing count per second, right? So now we're at 4 hours, so multiply that, and you get the number of seconds that we have on screen. And you see this sort of just kind of bands together, but we have breaks in the spectrogram here. These have longer epoch lengths. So the main thing to keep in mind is as you put more time in the screen, you're going to lose time resolution. Because when I zoomed out to 30 minutes, you can see this break in the spike detections, but when I go up to 6 hours, it's difficult to see. That break becomes very, very narrow. So when we're using the trends to help us just determine where we want to go to mark ranges, keep in mind that the duration of the trends can make it difficult to see some things that are very short duration, like spikes per second. When you put that many hours on, you can see the wax and wane, but the places where they abate shortly, if you have that much time in there, it becomes difficult to see. So I went down to an hour. That's a good time range, by the way, full page trends, for seizure hunting and seeing fluctuations in the trends that have a short epoch duration, like, for instance, the spike detections count per second. And so when it goes up a third of the way, it's 1 per second, 2/3, 2 per second, all the way up, it's counting 3 per second. Well, let's start here for marking. That looks good to me. So I'm going to go to the EEG page, and I have a button here to select range. So I'm just going to click that. But instead of having to page along, and I certainly could, I can just page along, I can grab this and move it to where I want it to go. That's fine. But I can use the trends because I've got a lot of pages to go, right, if I want to. So what I can do is click over here. Let's say I want that range to be there. I can page forward in the trends or scoot them forward. The single arrow, just bump it a little bit at a time, bump the trends a little bit at a time. The double arrow jumps it a full page. Let's say I want to go to where this break or where that spike rate seems to change. If I want to look at the EEG at the end of this range I've marked, I can go here. I can say, it starts slowing down a bit here. Maybe I want to go back further. Again, that range follows me wherever I go. So once I'm done, go back to the EEG page. Instead of clip, because I don't want to add a clip comment, I want to put a comment on here to do spike counting. So I'm going to do at spike count. You can do any comment. That's the default. You'll see that you could use at SWS or slow wave sleep if you want to use that. That's fine. Click OK. And now I've placed a comment with the duration here. And if we look at this, we can see there's one that I placed earlier. I'm just going to delete that comment, right-click on it. Here's a comment that I just placed. 63.93 seconds at spike count. There's the comment. Now, if I click on the comment, it takes me to the comment. You see the range there. If I want to modify this, by the way, I could double click on it. So, placed my comment. Let's place two of them. So I'm going to go back to the trends, and I'm going to page forward through the trends and pick a different spot to mark for calculating this. So you can see here the spike rate has dropped off. Spectrograms have changed quite a bit. I can, again, you can rescale these as you need to be able to see those changes, but we can see them pretty easily here. Go back to the EEG and we say, yep, they're not in continuous spike wave at this point. So let's go back to the trends and see where that begins to happen again. And well, it looks like the spikes are picking up here. I'm just going to click at this point, click the EEG, and page forward, and it's like, okay, let's say, there's some spikes in here, but I want to go to where it seems to be a little more consistent. So let's try at this spot, because this line gets a little more solid here. We'll click the EEG, and that looks more like it. Okay, so I'm going to pick this spot to mark my range, where this gets to be a little more consistent. I'll start here, go to the EEG. That looks good. I'm going to start marking a range. Then I can just page through this if I want to. Or I go to the trends, mark the endpoint, go back to the EEG. I'm just going to click comment. I'm going to put at spike count. Now I've got 2 of these. So there's 2 of them, and you can see the time and the duration. All right. So we've marked ranges. What do we do now? Well, we can go to tools. So we've marked the range that we want to do this calculation over. And so I go to spike index tool, and there's the comment it's going to look for. So if I had changed this to SWS or something, it would use that. The at symbol has no other significance other than when I sort these text comments by alpha, by just clicking the word text or clicking the word time, sorts them by time, I want these to be at the top of the list so I don't have to hunt through a long list of comments. So I put the at symbol, they're always at the top of the list. So I'm going to do spike calculation for rate over the ranges that are marked with at spike count. My epoch length is 1, my threshold is 1 for spikes in an epoch, which means if I have more than 1 spike per second, it's going to include that in its calculation of which, what the percentage of epochs that are true for spike wave will be. Tradition is, people would take 10 or usually 30-second epochs, they would page through and they would look at it and visually just say, is this epoch true for continuous spike wave? And they would say, well, it is true. And then they would page forward and say, well, this 30-second epoch is not true. But the variability in the spike rate in each one of those big epochs might change from human to human as far as what they would call it. And so using shorter epochs helps to get around that. Makes it a bit more granular, and your definition is, you can pretty much agree on it. If it's more than 1 spike per second, I'm going to count that 1 spike per second greater than for each second as being true for continuous spike wave. So, all right, let's say calculate. Well, here we go. So here's our 2 segments, and it calculated them over those 2 ranges. The spike sensitivity is high. Total elapsed time, 200 number of spikes in there, and 80%, 80.2% of the epochs exceeded the spike threshold of 1 per second. So there's your, so you can copy that to clipboard. Now, the other thing that is in P14 that is not in, I'm going to click the right button, not in P13, is that count only spikes marked for spike review. And what that allows you to do is to go into the spike review program, and you can pretty quickly say, I want this category spikes, and make this full screen. I'm going to turn off the maps, pick any montage you want. We'll just pick a bipolar. You can pick a category spikes to include in your spike count. So here's an average of all the T3s. Let's say I just wanted to do T3 spikes only, or T3 spikes and these spikes here, the FP2. So let's go ahead and select this group. We're going to mark all of them. We'll go back to the overview. We'll go to this group of spikes. I can mark all of these. When I go to Final Report, these are the ones that I've selected. I click the Final Report button in the upper left there. Again, from Overview, we go to Final Report. If I check these 2 groups, then when I go into Spike Wave Index, Spike Index tool, this is where I can count only the spikes I marked in the Final Report. So you can restrict by the spike focus for your spike wave index. In this case, we didn't do that. We just said, well, if it marks it as a spike, go ahead and do that. And there's our report. So that's a quick ad hoc screencast I run in the Spike Wave Index tool. And hope that was helpful with respect to FFT spectrogram scaling. By the way, that works for the rhythmicity spectrograms as well, to make them a little bit more helpful for seeing those changes. The effect of having longer trend lengths. If I put this together, those frequency trends do a very nice job of letting me know where there's state changes there. And I can see some changes here in the spike rate. But if I really want to see it in a more granular way, I'm going to have to bring that time level down, because breaks in that are very short in duration, if you crush everything together, it's hard to see. That's it. Again, this is Michael Guess. I'm a VP of Research and Clinical Applications for Persist. Always happy to connect by web conference. Hope this particular ad hoc screencast was helpful, and I hope it finds you safe and well. Thanks for listening.